Now that we've proved the inscribed angle theorem, there is an extra vocabulary word that I want to toss at you. Not the most important word, but if you're majoring in math when you get to college, it's a word you're going to come across quite a lot. And the word is corollary. And what a corollary is it's a fact, like a theorem, that's got a proof alongside it. But a corollary is a little bit less important than a theorem. A corollary is important enough that we want to state it and have it written down somewhere. But if we've got some theorem, there might be a few facts that are like super obvious once you know the theorem. And so we say, instead of giving this extra bonus fact kind of a theorem of its own, we call it a corollary, just to kind of hitch the two of them together. So this is something that we can see just by thinking about the inscribed angle theorem just a little bit deeper. Let's take a look at a diagram. All right, so I've got a circle with this kind of butterfly shaped figure in it. And let's think about, let's say that angle D has measure theta. I like giving that a nice Greek letter. All right, so what we know from the inscribed angle theorem is that if I drew a central angle like this, and that was the center O, this angle, what would its measure be? Well, it would be double the size of this inscribed angle. It would be 2 theta. Or another way of saying it is that the measure of this arc out here would be 2 theta. All right, so now that we know that, let's think about angle E here. What's the size of angle E? Do you know, based on looking at this diagram? Have I given you enough information? Does it depend on E, or is there enough facts in this diagram to make it clear how big angle E must be? Well, here's something about subtending arcs that I kind of want to make clear, and some students have had trouble with it, so I want to show you how to kind of do this with your hands. So if I want to be clear that this is the arc that's subtended by angle D, what I can do is I can use my hand to cover up kind of the bottom side, and so my other hand is covering this side. So I'm covering up everything except that angle, and you can see that the arc that is subtended by the angle is clearly the one that goes from B to C, that minor arc, because that's the only part of the arc that's not covered up by my hands. I could do the same thing if I wanted to talk about the arc that was inscribed by the central angle. So that central angle subtends the same arc. So that's how we know that there's that 2-to-1 ratio between those two sizes. Let's look at angle E down here. What arc does angle E subtend? Well, I'm going to do the same trick with my hands, and I'm going to see that it subtends the exact same arc as the ones we've been talking about up to this point. So what's the measure of this angle? Well, this is an inscribed angle of an arc with measure 2 pi, or another way of thinking about it is that it's an inscribed angle that's subtending the same arc as a central angle with measure 2 pi. So this inscribed angle must have a measure that's half of this. So this is also equal to theta degrees. All right. So what I just kind of did, if I covered up these extra red lines that I just created here, what I can see is that these two inscribed angles are congruent to each other. You probably saw this when you were in GeoGebra. If you had a figure like this and you were picking D and you were sliding it around the circumference of this circle, you may have noticed that the size of the angle didn't change as you were doing that. It stayed the same size, because the only thing that, that determines the angle of an inscribed angle is the arc that it subtends. So I would have to move one of these 2 points to change the size of this angle. So all of this conversation is leading up to this corollary of the inscribed angle theorem, which I've got written here. So if I've got 2 inscribed angles in a circle that subtend the same arc, like D and E, both subtend this arc here, angles D and E must be congruent. All right, so that's an important fact. We're going to get some use out of it, but it was just kind of one step further than just talking about the inscribed angle theorem itself. So that's why we give it this kind of slightly less important name of a corollary, just talking about how this is really a part of the inscribed angle theorem itself. But it's an important fact that we are going to use going forward, proving even more facts about circles and the lines and angles that they make up that circle as the videos progress. So keep tuned out for that and keep an eye open for those inscribed angles that subtend the same arc.